This is your example video for the Solving Quadratics Performance Assessment. You are going to be given a quadratic equation in standard form, and you are to solve this quadratic equation two different ways using two of the methods we have learned. When we say solve, that means we're trying to find the x-intercepts or the roots or the zeros. Okay, so the first way you need to solve this is by factoring and using the zero product property. And then for your second method, you get to choose between either using the quadratic formula or completing the square. So I'm going to solve this first by factoring and using the zero product property. So that is you have to solve it this way for sure, and then you get a choice in your second way. All right, so I am going to take my equation and I'm going to use my generic rectangle and my diamond. All right, so I have an x squared term, negative 15 ones. I'm going to multiply those together to get the top of my diamond. So I get negative 15 x squares. And then the number of x terms I have is what I'm going to put in the bottom of my diamond. And now I'm just thinking of those factors that are going to multiply to give me negative 15x squared and add up to give me 2x. So I'm thinking of either 1 times 15 or 3 times 5. And I'm going to go with 5x and 3x. So I know those differ by 2. And I have 2x in the bottom of my diamond. And then I just got to figure out which factor I need to put the negative on. And that's going to be the 3x. So that when I add up 5x and negative 3x, those add up to 2x. And when I multiply those two terms, I get negative 15x squared. So I'm going to put 5x and negative 3x into my generic rectangle. And then I'm going to figure out the dimensions of my rectangle. To get x squared, I know I'm going to have x times x. To get those 5 x's, I know that's got to be x times positive 5. To get negative 3x, that must be x times negative 3. And then I just want to verify that 5 times negative 3 does in fact give me negative 15, and it does. So now I've rewritten my equation that I was given in standard form. I've now written it in factored form. And since I want to solve this and I want to find the x-intercepts, I'm going to replace y with 0. Okay, because my x-intercepts happen where y equals 0. Using the zero product property, I'm going to take each of my factors and set them equal to 0 and solve for x. So I get that x equals negative 5 and x equals 3. Okay, so these are x-intercepts, so I can write them as coordinate points. So I have one root or one x-intercept at negative 5, 0, and another one at 3, 0. Okay, so now I have solved this quadratic equation by factoring and using the zero product property. Once I have my x-intercepts, I'm done. That's what it means by solving. Find your x-intercepts. So that's the first way. Then you want to do it a second way. And on your second choice, you get to choose, or your second method, you get to choose between completing the square and using the quadratic formula. Okay, you only have to do it one of those two ways, quadratic formula or completing the square. I will show you both, but know that you are going to solve it once by factoring, and then the second time you choose quadratic formula or completing the square. All right, so I'm going to start with completing the square. So rewrite my equation. Okay, now I'm starting with the same equation, so I should get the same roots, the same x-intercepts. I'm just going to go find them a different way now. All right, so when I'm completing the square, I'm going to draw the picture of what's happening here. I'm going to right away go ahead and just let y equal 0, okay, because I know that I'm trying to find my x-intercepts, and those happen when y equals 0. And I'm going to just draw my equation mat here. Okay, I'm going to have 0 on the left side, and on the right side, let's draw a picture of what I have. So I have an x squared tile. Make that blue because it's positive. So I have an x squared tile, and then I have 2 x's, right? I'm trying to make a square, so I'm going to split those up evenly. So I'm going to put 1 above my x squared tile, and 1 of those x's to the side. So I'm trying to make a perfect square here. And then I got to figure out what I'm going to have in this corner. Well, I know the dimensions of this perfect square are going to be x plus 1 times x plus 1. So I know that this corner, well, it's got to be 1 times 1. So that corner has to have 1 tile in it, okay? I currently have negative 15 ones, right? If I need there to be a 1 there, well, I'm going to have to add in 16 ones, so that when I add those two numbers together, I'm left with 1 tile. If I added 16 tiles into the right-hand side of my equation, I've got to do it on the left. Okay, so now here's what we have. On the left-hand side, we have 16 ones, and on the right, we've got our perfect square, x plus 1 squared. All right. Now remember, my goal is to figure out what x equals, so I'm going to undo this until I get x alone. So the first thing I'm going to do is take the square root of both sides. Remember, when I do that, it's always plus or minus, because we can get positive or a negative number there. So a square root undoes a square. So on the right, I'm left with x plus 1. And on the left-hand side here, I know the square root of 16 is 4, so I have plus or minus 4. I want to keep going so I can get the x alone, so I'm going to take away 1 from both sides, because that's 0. And I have x equals negative 1 plus or minus 4. So if I keep going here, I have negative 1 plus 4 is equal to x. And I have negative 1 minus 4 is equal to x. And when I solve this, I get that our x is equal to 3, or our x is equal to negative 5. And again, I want to write these as coordinate points, because these are my x-intercepts of my parabola. And you can see that when I did that, I have the same answers that I got when I factored this problem. All right, so I'm going to show you how you could solve this using the quadratic formula if you choose to do that method for your second way of solving this problem. So now we're going to look at the quadratic formula. All right, and again, my original problem was y equals x squared plus 2x minus 15. All right, so the first thing I like to do when I use the quadratic formula is write it down. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And again, I'm going to let my y equal 0 because I'm trying to find my x-intercepts. And before I start putting numbers into my quadratic formula, I like to say what a, b, and c is, okay? So remember, the term or the coefficient in front of your x squared term is the a value, so there's a 1 right in front of that x squared. The b value is the coefficient in front of your x term, so that in this case is 2. And then my c value is the number of ones I have, so I have negative 15 ones. Okay, so now I'm just going to go through and replace a, b, and c with what they're equal to. So negative b, let's see, my b is equal to 2, plus or minus the square root of b squared. Again, b is 2, minus 4 times a, my a is 1, times c, which is negative 15, all divided by 2 times a. My a is 1. All right, and keep going through and solve here. So the opposite of 2 gives me negative 2, plus or minus. I'm going to try to write down every single step because there's a lot of places I can make mistakes, so I want to be very careful as I go through and solve this. So 4 squared is 4. And then here I have a negative 4 times 1 times negative 15. So that ends up being a negative 4 times a negative 15, which gives me positive 60. And then this is all divided by 2 times 1 gives me 2. So I have x equals negative 2 plus or minus the square root of 64, all divided by 2. Keep solving. So I get negative 2 plus or minus the square root of 64 is 8, all divided by 2. And now I have two situations here, two x values that we're solving for. So we have negative 2 plus 8 divided by 2. And the other one is negative 2 minus 8 divided by 2. So in the one on the left here, I get negative 2 plus 8 is 6 divided by 2, which gives me x equals 3. So one of my x-intercepts is 3, 0. And my other one, negative 2 minus 8 is negative 10 divided by 2. So we get that x equals negative 5. So there is my other x-intercept. So you can see, no matter the method, I get the same x-intercepts, the same roots. Okay, so as a reminder again, you are going to solve this two ways. The first way you have to solve it is by factoring and using the zero product property. Okay, that is one way you need to do it. Then for your second way, you choose to either complete the square or use the quadratic formula. And then just make sure that you are writing out all your steps and describing what you're doing as you write out your work.